Alright everyone, today we'll be talking about linear inequalities. So in this section you're going to learn what a linear inequality is, how to solve a linear inequality, the two different types of compound inequalities, and then how to solve those. So first of all, let's start by just reviewing how to solve a linear equation. Here we have 9x minus 4 is equal to 2 times 4x minus 7. We want to distribute first, and then add our like terms. So we're going to distribute the 2, and we'll get 9x minus 4 is equal to 8x minus 14. Subtract 8x from both sides. 9x minus 8x is just x minus 4 is equal to negative 14. Add 4 to both sides, and we get x equals negative 10. So the steps for solving a linear inequality is very similar to solving a linear equation, the same steps we just did, with two major differences. First of all, instead of a single solution, inequalities often have an interval as a solution. So they have more than one number that would be a solution. Remember that inequalities use inequality symbols, greater than or less than, greater than, less than, greater than or equal to, or less than or equal to, in place of an equal sign. Those will be in place of the equal sign. That's how they're going to look different. But instead of a single solution, inequalities often have an interval as a solution. So we're going to be writing our answers in interval notation. And the other really big difference between linear equations and linear inequalities is that if you divide by a negative number, then you have to flip the inequality sign. And we'll see a few examples of that. Most of your answers will be given in interval notation, so there's some helpful things to remember when we talk about interval notation for inequalities. If you use a less than or equal to, greater than or equal to, remember that you're going to use brackets. That equal to symbol means you can equal that number, so brackets would be appropriate. If you use a greater than or a less than sign, then just use parentheses. And remember that anytime infinity is involved, you're always going to use parentheses. You can never equal infinity, so infinity will always get a parenthesis. And so in some cases it may be helpful to graph the solution set in a number line. We're going to do that throughout this lesson, just to show you how to do it and how it can help. So first, we want to find the solution to the inequality. We're going to graph the answer on the number line and then write the answer in interval notation. So the first thing we need to do is solve this problem. We have 2 times x minus 5 is greater than or equal to 5x minus 8x plus 15. So first, let's distribute and combine our like terms. We're going to distribute the 2. 2 times x is 2x. 2 times negative 5 is negative 10. It's greater than or equal to 5x minus 8x is negative 3x plus 15. Let's then subtract 2x from both sides. And we're going to get negative 10 is greater than or equal to negative 5x plus 15. And now we'll subtract 15 from both sides. And we'll get negative 25 is greater than or equal to negative 5x. And so now we can divide both sides by negative 5. But remember, when we deal with inequalities, if you divide by a negative number, the inequality flips. So now what we're going to get, negative 25 divided by negative 5 is positive 5. Our inequality symbol is going to flip around so that now we have less than or equal to x. Or x is greater than or equal to 5. If 5 is less than or equal to x, then x is greater than or equal to 5. So if we want to put that on the number line, we're going to look down at 5. Here's 5. We want all the numbers bigger than 5, greater than or equal to. And because it can be equal to, we're going to use a bracket. So we're going to use a bracket at 5 and all the numbers to the right of 5. So when using a number line, it's helpful to remember that on the left is negative infinity, and on the right is positive infinity. And now when we want to write our answers in interval notation, we're always going to start from the left and go to the right. And so in interval notation, our answer is going to be positive 5 with a bracket, because it's greater than or equal to, all the way up to positive infinity. And infinity always gets a parenthesis. So let's try another example. We're going to solve this inequality, and we're going to graph it on a number line and write our answer in interval notation. Negative 4x plus 6 is less than 16. So let's subtract 6 from both sides. We get negative 4x is less than 10. Divide by negative 4, but once again, if we divide by a negative number, our inequality flips, and we're going to get x is greater than negative 10 over 4, which is the same thing as x is greater than negative 5 over 2. So that's our solution. Now we want to graph it on the number line. Well, negative 5 over 2, that's negative 2.5. And we know x is going to be greater than that, but not equal to, so we get a parentheses. And all the numbers greater and so if we want to write our answer in interval notation, it's going to be parentheses, negative 5 halves, because that's where we started from, to positive infinity. Infinity always gets a parenthesis. Compound inequalities are when you have more than one inequality involved in a problem. There are two types of compound inequalities, two ways we can combine these inequalities together. The first are known as AND problems, and this just means that solutions to the problem have to satisfy both of the inequalities in the problem. And then we have OR problems, which just says that the solutions to the entire problem overall only have to satisfy one of the two inequalities. And we're going to use number line graphs to help us figure out solutions, and I'll show you how to do that as we go along. So here's our first example. We have a compound inequality, and this is an AND problem. There are two inequalities, and this means that solutions to this problem overall should be solutions that satisfy both of the given inequalities. So first we need to solve both of the inequalities. Well, over here we have negative 3x is greater than or equal to 6. If we divide by negative 3, once again our inequality flips. We're going to get x is less than or equal to negative 2. On this top number line, we're just going to graph x is less than or equal to negative 2. Well, equal to means we can get a bracket, and less than is going to be everything in that direction. So let's do the second inequality. We have x minus 5 is greater than negative 12. If we add 5 to both sides, we're going to get x is greater than negative 7. So greater than negative 7 on our second line, we're going to use a parentheses, and everything greater than negative 7. Now we're going to use the third number line to determine our answer. And problems have solutions in such a way that they have to satisfy both inequalities. So our solutions are going to be, if these two lines were written on top of each other, where would they overlap? So let's draw them both on top of each other. And the place where the lines overlap will be the solution to the compound inequality. And so here we can see they overlap from negative 7 to negative 2. And so in interval notation, our solution would be parentheses, -7 to -2 with a bracket. So when you're dealing with and problems, you're looking for where do the two lines overlap. Now, not all and problems will have and written on them. Some of them are written slightly differently. This is still a compound inequality, and this is still an and problem. However, we have two separate inequalities. On the left-hand side, we have -4 less than or equal to -2x plus 5. And on the right-hand side, we have -2x plus 5 is less than 13. We're going to solve these two inequalities and then graph them and do the same thing we just did. For the first one, we're going to subtract 5 from both sides. We're going to get -2x, sorry, -9 is less than or equal to -2x. Divide by -2. Remember our inequality flips, and we're going to get x 9/2 is greater than or equal to x. So that means x is less than or equal to 9/2, because 9/2 must be greater than x. And so 9/2 is the same thing as 4.5. And so we're going to go to 4.5. We're going to get a bracket, and everything less than 4.5 is 9/2. Now we need to solve the second inequality. We're just going to subtract 5 from both sides. We get -2x is less than 8. Divide by -2, and we get x is greater than, because the inequality flips, -4. So here's -4. We're going to go greater than -4. And so now on the bottom line, we're just going to look for where these two lines would overlap, and we would see that they would overlap between -4 and 9/2. And so our solution in interval notation, -4 and 9/2. Let's try another example. We want to solve this compound inequality, very similar to another and problem. So we're going to do the same thing. We have 2x minus 4 is greater than 8. We're going to add 4 to both sides. We get 2x is greater than 12. Divide by 2. We get x is greater than 6. So let's put that on the first line. For the second line, we have 7x is less than or equal to -49. We're going to divide by 7. We get x is less than or equal to -7. So on the second line, less than or equal to -7. Now if we put these two lines together onto the same line, they're not going to overlap anywhere. There are no numbers that are greater than 6 and less than or equal to -7. And so because that's the case there, because there are no numbers that will satisfy both inequalities, then this compound inequality has no solution. Okay, let's try another one. Solve the compound inequality, and then we're going to write our answer in interval notation, but this time it's an OR problem. Remember that OR problems, you only have to satisfy one of the two. So now we have -1/2 x is less than or equal to 1. We're going to multiply both sides by -2, or essentially we're dividing by -1/2. If you multiply or divide by a negative number, the inequality flips. And so if we multiply both sides by -2, Negative 2 times negative 1/2 is going to be positive 1x greater than or equal to negative 2. When we multiply by a negative, the inequality also flips. And so we get x is greater than or equal to negative 2. So we'll put that on our first line. For the second line, we have x minus 3 is less than or equal to negative 7. And so we're going to add 3 to both sides. And we get x is less than or equal to negative 4. Now, once again, let's write both lines on the bottom line. But because this is an OR problem, we're not looking for where the lines overlap. When we deal with an OR problem, we're only looking for parts of the line that are shaded. Anything that's shaded is part of the answer. So what we have is two sets of numbers. On the left, we have minus infinity to negative 4 with a bracket. On the right, we have negative 2 to positive infinity. Those are both of our solution sets. We want to combine them together into one set. And so what we'll get is negative infinity to negative 4 with a bracket. And then another bracket, negative 2 to positive infinity. And between these two, we just put a U. It's a symbol for a union. Union just combines the two sets together and says that these two sets of numbers are one. And so your solution in interval notation should look like that. Let's try one final example. We've got another compound inequality. It's also an OR problem. And so we have 4x plus 5 is greater than or equal to negative 3. We can subtract 5 from both sides. We get 4x is greater than or equal to negative 8. Divide by 4, and we get x is greater than or equal to negative 2. So on our first line, x is greater than or equal to negative 2. Now on the second inequality of x minus 2 is greater than 9. Add 2 to both sides. And we get x is greater than 11. Well, 11 is not quite on this second line, but we can kind of put it there. Here's 11, and everything greater than 11. Well, now, our problem just says that anything that's shaded is part of the answer. So anything that's shaded is part of the answer. The first line starts at negative 2 and contains all values up to positive infinity. The second line doesn't start to 11, but it goes all the way to positive infinity. So if we wanted to account for everything that's shaded, our interval would just be from negative 2 to positive infinity. And so finally, at the end of this lesson, you should be able to solve a linear inequality and write the answer in interval notation. And you should be able to solve a compound inequality and graph the answers on a number line.